Concept 3, solving literal equations for a variable. So a literal equation is just an equation that has more than one variable in it. It can also have numbers and values and operations, but it has to have at least two variables. Okay? And the thing about having more than one variable in an equation is you can't solve it to get a value. You can't solve this equation, which is speed equals distance over time, and get a value unless you plug in values for your other variables. Okay, so I could plug in values. I could say that I went 8 feet in 1 second, and then my speed would be 8 feet per second. All right, or 8 feet per 2 seconds, and then my speed would be 4 feet per second. Okay, so I could plug in values to get a number as my solution, but usually I'm just going to have this as my solution. Okay, I'm going to have my variable isolated. So this is a literal equation which is solved for speed. Okay, speed is by itself. All right. So if I have the same equation, but I want to solve for distance, my goal is to isolate the variable that I'm trying to solve for. Okay, I'm trying to get d all by itself. So if I have distance over time, I'm dividing by time, so I'm going to multiply by time on both sides and cancel those, and that gives me distance is equal to speed times time. Okay, and that makes sense when we think about it. How far did I run? Well, I was going 3 miles an hour. Well, that's really slow. 5 miles an hour. That's pretty fast. That's fine. 5 miles an hour, and I ran for 2 hours, so I ran 10 miles. Right? Okay. All right. So now let's look at some other ones, some that you should be familiar with. This is the area of a circle. So the area equals pi r squared. We want to solve for r, solve for the radius. So we're going to start by trying to get the radius by itself. I'm going to divide by pi, okay? And then I have r squared is equal to area over pi. And then I want to get rid of the squared, right? Because I'm not trying to solve for r squared, I'm trying to solve for r. Oops. So I'm going to take the square root. Okay? Square root cancels that. Whatever I do to one side, I do to the other. And I have that the radius is equal to the square root of the area over pi. And that's my solution. I'm done. Okay? We'll look at one more real quick. All right, so this is my formula for the volume of a triangular pyramid. All right, and I want to solve for h, for big H, for the big height. Okay, so this is all multiplication. So actually, what I can do is I can just say, okay, I want h. I'm going to divide by everything here, right? I'm going to divide by 1/3 times 1/2 times base times height. All right, and that'll all cancel out. And over here I have volume over 1/3 times 1/2 times base times height. Okay, and that actually is a solved formula, right? The total height is equal to the volume over 1/3 times 1/2 times base times height. Okay, we could simplify this a little bit more because we have fractions in our denominator. We can actually just flip them, right? We can multiply them together, and then they just basically flip up above the division sign. Okay, because we're dividing a fraction. Remember, if you're dividing by a fraction, keep, change, flip. All right. So this would end up being h is equal to volume over base times height, and then the volume is going to be times 3 times 2, or volume times 6, 6v over b times h is equal to the height. Okay? So for solving literal equations, you're really just moving things around. All right? You're just moving values around until you get your variable that you're trying to solve for isolated.